You know, have you ever stopped and just really looked at your own eyes and wondered what's the story there? Because it's way more than just genetics. It's this incredible tale of survival, of physics, and a journey our ancestors took thousands of years ago, all wrapped up in the color of your iris. So let's decode that story together.
Yeah, that color you see looking back at you in the mirror, it is definitely not random. It's a direct link, a roadmap, really, to your ancestors. Where they lived, how they survived, whether they were dealing with the blazing sun of the savanna or the super dim light of a frozen tundra, their story, that story of adaptation, it's right there, looking back at you.
All right, so here's what we've got lined up. First, we're going to get into the basic science. The simple dance between pigment and physics that makes every eye color possible. Then, we'll look at why brown eyes are basically nature's sunglasses. After that, we'll travel north to see how light eyes evolved for darkness. We'll check out the rarest, most artistic colors, and we'll wrap things up with a look at the wild genetic anomaly of having two different colored eyes.
Okay, so how does an eye actually get its color? Well, it really all comes down to two simple but super powerful forces. The first one is biology. It's all about how much of a certain pigment you've got. And the second one? That's pure physics, the incredible way your eye plays with light. Let's break that down.
Okay, get ready for the first really surprising fact. Every single eye color on the planet comes from just one pigment. And guess what? It's brown. It's called melanin. So if your iris is just packed with a ton of melanin, it soaks up most of the light, and boom, you've got brown eyes. But if you have very little melanin, something amazing happens. The light doesn't get absorbed, it gets scattered. And that scatter creates the illusion of blue. So it's not about having different colored pigments, it's all about how much you have. It's all about quantity.
All right, let's start with humanity's original blueprint, you could say. We're talking about the eye color that's not only the most common on the planet, but was also perfectly designed for living under a bright, powerful sun.
And this really puts it all into perspective, doesn't it? I mean, over 70% of all people on Earth have brown eyes. That is no accident. Nope, that is the result of a seriously powerful evolutionary advantage that's been shaping our species for thousands of years.
So what's the big advantage? Well, it's all about protection. Think about it. That high concentration of melanin in brown eyes literally acts like a pair of built-in sunglasses. It absorbs harmful UV radiation and cuts down on glare, which, you can imagine, was absolutely essential for surviving in super sunny places like the African savanna. This trait just makes you less sensitive to bright light and lowers the risk of certain eye conditions. Pretty effective, right?
So, you might be wondering, what about black eyes? Well, it turns out they're not really black at all. They're just the most extreme version of this advantage, a super, super dark brown that is packed with the highest possible amount of melanin. These eyes absorb almost all the light that hits them, giving them the ultimate natural defense against the sun.
But, survival is never static. Humans move. So what happened when people migrated away from the equator into the darker, colder parts of the world? Well, the evolutionary pressures completely changed, and a pretty radical new adaptation popped up in our eyes.
Okay, get ready for another mind-bending fact because this one's a doozy. Blue eyes have absolutely zero blue pigment in them. None. Zilch. Their color is just a beautiful illusion created by physics. See, with so little melanin there to absorb light, the tiny fibers inside the iris scatter it instead. And it's the exact same reason the sky looks blue. The iris just reflects the shorter, blue wavelengths of light right back at us. Isn't that wild?
And here's where the story gets even more incredible. Every single person with blue eyes alive today is related. Seriously, they can all trace their ancestry back to one single individual who lived around 10,000 years ago near the Black Sea. Just one mutation happened that dialed down melanin production, and that let more light into the eye, which was a huge advantage for seeing better in those dim, overcast winters in Northern Europe.
And gray eyes, well, they've pretty much take this low melanin thing to the absolute extreme. They have even less pigment than blue eyes, which makes the light scatter even more, well, diffusely. And that's what creates that really distinct, cool, silvery look. You could say it's the ultimate version of an eye that's adapted for low light.
Okay, now we get to the really complex, artistic colors. These are the ones that aren't just about having high or low melanin. Nope, they're a unique, beautiful blend of both pigments and physics.
Just take a look at how incredibly rare these colors are. Green eyes? Only about 2% of the world's population has them. And gray and amber are right there with them, just as scarce.
See, these aren't simple on or off genetic switches. They're more like really intricate recipes.
So what's the secret recipe? Well, it's all about mixing that base layer of melanin with another, faint yellow pigment called lipochrome. For green eyes, for instance, you're basically combining the light-scattering physics of blue eyes with just a little bit of that yellow pigment. Hazel eyes? They have a bit more of the brown melanin thrown into the mix, and that's what gives them that amazing, almost chameleon-like ability to shift color. And then you have amber eyes, which happen when you have a lot of that yellow lipochrome, but very little melanin, creating that solid, stunning golden color.
And finally, let's look at one of the most visually striking and rare things in all of human genetics. This is what happens when the rules of symmetry get, well, beautifully broken.
This condition is called heterochromia. And it's basically what happens when the body's plan for distributing melanin goes a little off script while you're developing. The result can be two completely different colored eyes, or even these fascinating patches of different colors inside just one iris.
And as you can see, we are talking about a true genetic rarity here. Fewer than 1% of the entire human population has heterochromia. That makes it one of nature's most beautiful and definitely most fascinating outliers.
Now, it's important to note that for the vast majority of people who are born with it, heterochromia is completely harmless. It's just a tiny genetic quirk that has no effect on your vision at all. Its real impact is purely visual. It breaks that perfect symmetry our brains are kind of hardwired to expect in a face. And maybe, just maybe, that's exactly why we find it so captivating.
So, from nature's built-in sunglasses in the sunny south, to those clever adaptations for darkness in the north, and all the rare artistic blends in between, your eye color really does tell a profound story. It's the story of where your ancestors came from and exactly how they survived. So the next time you look in the mirror, just remember, you're looking at thousands and thousands of years of human history. The real question is, what story do your eyes tell?